Okay, today we are at San Diego State University, and we're in the electron microscope lab with the prestigious Dr. Steven Barlow. And he's going to explain to us a little bit about what this program is and a little bit about San Diego State University. So right now he's looking up some samples, and I believe he's looking at Drink Me microbially activated filtration sand.
This is actually the other sample.
Oh, this is the other sample. So this is a CO2 sample that was condensed from CO2 gas back into a carbon structure. And we're going to find out what this carbon structure is made of and some of the components of it.
So this is an image on the scanning electron microscope. This is a field emission source of electrons, so it's a very high resolution scanning microscope that's going to scan a beam of electrons over the surface of the sample. And at each of these spots, as it's scanning, it's going to record the interaction of the electrons sourced with the sample, the atoms of the sample, and look at how many electrons are being released from the sample. A large number of releases of electrons will give a bright spot on the screen, and the area that is not releasing as many electrons will give a dark spot on the screen. And by assembling all of those data points together, we create an image which we're seeing up here on the screen. The instrument itself is located at San Diego State University. It's a member of the California State University system, which was originally a teachers college that then became a college for students, and then more recently it's become a university, and over the years has developed a strong research program with the faculty members who've been hired to teach classes and also then get engaged in scientific research, which they involve their students in. That gives the students an opportunity to see what it's like to be a scientist in our particular field. Obviously in the biology department, so I'm describing your experiences, students' experiences as they would be in the biology department. But all the different departments on campus engage in research of one kind or another. You have people in the English department who will be looking at text and creative writing, etc. But in the sciences, we're looking oftentimes with this high-end equipment like this. I teach classes on how students can learn how to use this equipment, and that can be used as part of research projects. It can also function as some preliminary training for students to then go on to apply for jobs. So when they apply for that job, the interviewer may ask if they've ever used a frick-frack machine, and the student's response would be, no, I've never used a frick-frack machine, but I have used an electron microscope, so that demonstrates that I know how to work with computer-controlled instrumentation, that I know how to keep notes on research, on my research experiments, etc., like that. So that's the advantage of having research going on and having students participate in those endeavors. And the students can, as a result of having been active participants in the work, can then participate by having that work published, and the students are authors on those publications. They will often attend meetings and present their results, and then use those to go on for further endeavors either in academia or in industry.
You have no idea how refreshing that just sounded. Coming from the entire world that we come from the free energy world, it's usually the contrary. When you have some grassroots garage.com type idea, it's very difficult to get into academia, and I'm very extremely appreciative of your time today allowing me to do this. So thank you very much. And we're going to be looking at several samples, but this is a good introduction, and thank you very much, sir.
Sure.
All right. Take care, and see you soon.